Hi, I'm Chet Haas, an engineer on the Android team at Google. I work on graphics and animation, but today I'm going to talk about something a little bit different, a little bit of animation, but it's more about doing things wrong. So this is the first in possibly an ongoing series, which I like to call You're Doing It Wrong. So the demo I'm going to show you today, this is really hacked up, as many of my demos are, and very obvious, and you may not do things exactly this way. But these are examples taken from real apps shipping on the device, where we've seen approaches like this, or like this in a maybe much more complex and not as obviously bad way. So it's important to sort of take the main idea away from it, if not the exact implementation. So in particular, I want to look at ListView and the idea that there's a distinction between the position of items on the screen and the views that represent the content in those items. And you should understand those differences very carefully for the following reason. So let's take a look at the demo, which I call ListView Deletion. And we've got a list of cheeses on the screen. We can select several of these, and we want to select the ones that we're getting rid of, so we click the delete selected. They fade out, so that's the animation part of this thing. They fade out, and then we remove them from the adapter, and the ListView updates, and all things are wonderful. But what happens if we select a few of these, and then we scroll down, and okay, we'll go ahead and run the deletion. Okay, let's run that one again. If I could slow-mo this, I would. Notice that there are things fading out on the screen that have nothing to do with the ones that are checked. In fact, if I scroll all the checked ones off the screen, nothing should fade out because none of these items are actually selected, right? So they shouldn't be removed, but they are. But actually the content of the items themselves is not being deleted. What's being deleted are the views, right? So we fade out the view and then we delete the items. Well, the items that are being deleted are not the views that are being faded out. So what's going on? So there's a concept in ListView of view recycling. This is done because you can have list views of enormous size with tons of views in them, and we don't want to instantiate all of those things and have them persistent in the state of the activity at all times, and we don't want to have to update all this stuff every time we redraw the list view. So instead, we have active views for the items that are on the screen at the time, and as views scroll off, those views get recycled and used for other content on the screen. It's very nice. It makes ListView very smooth to fling and to scroll and to interact with. However, it means that if you are assuming things about the specific views that are being used in a ListView, you're doing it wrong. It's important to understand that ListView, you should really think of it as a holder of content, and that you need to really interact with that content in terms of the adapter directly and not necessarily the views on the screen, or else you at least need to know what you're doing. So let's take a look at the code and see what the application is doing wrong. So we have this ListView deletion class. We create this array list holding this large list of cheeses, terribly interesting content. And then we have this set on click listener for the delete button. So when you click the button, it figures out what to delete and runs animations and removes things appropriately. Oh, and then there's some code down here where when you actually checked on these things, so we can take a look at that. On item click listener for the checkbox, it basically adds these views to this list of checked views there. So we track that. Now this is kind of the hack part of the demo where we're actually tracking, the views that are actually being deleted for the purposes of the demo. So we go through here and we go through the checked items of the list view, and this is the default code, which is bad, which is, okay, we're not, this checkbox to control the behavior is not currently checked, so we're gonna run the code that we thought was obvious, and we're going to simply remove, we're going to fade out views and remove them. So first of all, we're going to post this delayed thing to actually remove it from the adapter. After the fade animation is done, we know that the animation is going to take 300 milliseconds. The actual animation is run down here, where we iterate through the checked views list, and for each one of those, we grab the view that was checked and we run an animation on it. This is using the View Property Animator API, which was introduced in the 3.2 release. So we say animate the alpha property to 0, and when you finish, let's restore the alpha property because that's good practice, otherwise the thing stays invisible. So all of that looks good, except for the part where if you scrolled off the screen, that view got recycled and reused by completely different content. So now we're going to fade out the view, which has nothing to do with the content that was checked, which is now sitting off the screen. Bad way to go. If we go back and look at the demo again, and we say use positions instead of use views, and we check a bunch of things on here, and then we run this thing. Well, of course it does the right thing when they're on the screen anyway, but if we scroll these things off the screen, then it fades out only the ones that are actually selected that are on the screen. And that logic works as follows. So in here, we go into the else clause. First of all, we clear this thing so that we're not going to run animations on these, because we have a different way of managing our animations in this approach. We get the position on the screen, so we can get the first visible position, and then everything after that is numbered after that position. So we can say, okay, this is the first visible position, and then we iterate through. So this is the number of checked items. So we're actually iterating through the list view items here. So we can get the position of the list view item itself, the position of the first visible position, and then figure out whether that thing is actually on screen. And if it's not on screen, don't run an animation at all. Just remove the thing. In fact, we should remove it after we're done so that it doesn't blink the list and move stuff around at the time. But we basically use that as a trigger to determine whether it's on screen, therefore run an animation on that thing, or it's off screen, don't bother with the animation, just remove it when all the animations are done. So if it is on screen, then we do a similar animation as we did before. We animate the alpha property on that view with an end action to restore alpha. And after we've restored alpha, then we remove it from the adapter. So all the animation code before was good. What wasn't good was that we were using a view that was determined at check time, not at the time when we were actually telling the system to delete and we knew what was actually on the screen at the time. So the takeaway here is be aware of the position of your items on the screen, be aware that your views can be recycled, and be aware that there's a really large disconnect potentially between those positions and the views and the data underneath that the views happen to be displaying at any point in time. So thanks.